Oh, good day once again. In the last video, I've shown you an example program to compute the fourth factorial in the analytical engine without using a loop. In this video, I'm going to show you two more simple examples that are used to convert values using the analytical engine machine. The first example which I'm going to demonstrate is conversion of meters to feet. This is a typical activity when when you convert distance measures differently from meters to feet. So the formula for converting meters to feet is simple. You multiply the given meters value by a constant 3.28 and you get the equivalent value in feet. So in this case, we will have three inputs. The original value in meters and the multiplier which is at 3.28, and we will have an extra 90 case we need one, just the value of one. Okay, so the first command is the assignment statement n0004, which means that we store the value 4 into our meters variable, which is 000, and then we have n001 space 3.28. We store the value 3.28 to variable 001. Now in other examples, 3.28 is usually multiplied by 100, so that you will have 328, and all the other inputs are also multiplied the same value, so we'll have 400. That is when you do not want to use decimal values. But the references from the internet shows that the analytical engine can store the fixed point decimal values. So for convenience, we will allow 3.28 to be assigned to variables. And then the first command right away is a times or a multiplication, which comes in our next operation card, followed by L00. With L00, the value 4, which is in variable 00, will be stored in ingress axis 1. And when we say L001, the value of 3.28 will be stored in uh, ingress axis 2. And the result is stored in the egress axis. So the resulting value, which is 13.12, is stored in the uh, egress axis. And we store the result to ST002 just to save the variable. So this will become 13.12. Okay. We are done with the simple computation. We can issue a P to save the value in the last card. And we ring the bell and we halt the engine. So a very simple example. You can also work the reverse, such as converting feet to meters. You can also use this to convert values from one currency to another, and so on and so forth. The next example, which I'm going to show you, it's a much more complicated formula, which is used for converting Fahrenheit to Celsius. Here's the program. Let me erase the trace first. Okay. The simple formula for converting Fahrenheit to Celsius is, first we subtract the value 32, and then after which we multiply the value 5 and we divide the value 9. So we are using uh, four variables from 00 to 003, in which case the variable 00 is used here as the Fahrenheit value. Subtrahend 32 is stored in variable 001. The multiplier 5 is stored in variable 002, and the divisor 9 is stored in variable 003. We are going to store the final result to uh, value 001. Okay, so let's start right away. The first operation card is a minus. L00 is 132, which is our Fahrenheit value, and L001 is 32, which is our subtrahend. So the L00 and the L001 operator will subtract 32 from 132, which sets the value 100 to the egress axis. and we store it to S001. So this will now have 100. Okay, you can pause the video and check if the answers are correct. The second operation is at times. We do this to multiply the result by 5. So L001 is 100, L002 is 5. So this will become 500. So 100 times 5 is 500, and we will store it here. Our final result will be on this value also, which is 001. We do a divide, okay, which finally will divide the resulting value by 9. L001 is 500 and L003 is 9. So the resulting value is 55.55. We'll store the result. We say S001 prime. So this will become 55.556. What is the prime all about? This is only used in division, because in division the quotient is in the prime egress axis and the remainder is in the egress axis. Therefore, we put a prime to indicate that it is the prime egress axis which is stored to variable 001. And succeedingly, we'll have a print to print the result to the last card, and B for the bell, H for the halt. That completes our conversion process. In the next video, I'm going to show an example which computes the nth factorial using a loop. Thank you and see you in the next video.